Hey guys, we're gonna get started here, so pay attention. Tomorrow we are gonna have a little quiz, like I'd mentioned, on everything up to what we've done. It won't include this stuff today. A couple of the things we're gonna look at are things that you've already seen, just like in a slightly different way, maybe. Some of it's actually I've shown you already, so it won't be new at all. Some things, though, will be new. So we're looking at conditional probability here. Conditional probability means that something, like, we're looking at two different events happening, and one of them will depend on something else. So, like, if you ever hear, like, conditional acceptance from universities, conditional acceptance means that you're being accepted assuming that your grades stay the same. This is stuff like that, where it's like, we're looking at probability, but it is sort of assuming, or it's based on something else. It's the same kind of idea. So here, the first question is one that basically we've seen already. It's not a new type of question. A computer manufacturer knows that in a box of 100 chips, 3 will be defective. Jocelyn draws 2 chips at random from a box of 100 chips. Determine the probability that she'll draw 2 defective chips. So we could have done this question in the counting methods unit, and we could have used counting methods for it. But if you're doing conditional probability, you just look at it as 2 separate events. So you look at her drawing the first chip, and then the second chip. Now we would say that the first chip, or the second chip depends on the first, because once we draw the first chip, there's going to be fewer chips in the total. So the first chip, it's like out of 100, okay, how many of those are defective? 2, right? Oh, 3, sorry, 3, you're right. 3 chips will be defective, so it's 3 out of 100. Then for the second thing, this is where the conditional part of it comes in. We assume that we pulled a defective chip in the first part. Okay, we're assuming that we've pulled one out, because if we haven't, this question's over, right? Like, we're looking for the possibility of her pulling 2 defective chips. So she needs to pull both times the defective chip. So now we assume she's already pulled 1 defective chip. So now how many chips are there in total for her to select from? 99. And how many of those are defective? 2. So when you do this, you just multiply these 2 events together, and it gives you the total possibility. So it's times 2 over 99, and it just gives you a very low number. Now it says this, so I'm going to go over this again because this gives people trouble on the test often. 06. Okay, it keeps going. And then it says E -4. Okay? Now, this is a decimal answer, okay? And what it really means is it means 0.000660, okay, so forth. That's what it means. So what it's telling you is that there's 4 places after that decimal, or before that decimal. Okay, so that's what it means. It's 0.0006060. I shouldn't see answers like this on your test.
Excuse the interruption. Mr. Messier, please contact the office. Mr. Messier, please contact
Mr. Messier's gone missing. He's like, usually when they call somebody, it's because like a student's taken off or something. I love it's like Mr. Messier. He's probably disappeared. So that would be the decimal answer. As a percentage, if I wanted to get that as a percent, what would I do? Times it by 100. So I just go times 100 on the calculator, and it gives me 0.06%. Now, generally speaking, I'm not going to tell you what form you have to use. I'm not going to say as a percent or as a decimal or as sometimes I will, I guess, but not usually. I'll just say what's the probability. And you can kind of use whatever method you want. Like, you could even leave it as a fraction. Like a fine answer here would be 6 over 9,900. I mean, that's not a fraction in lowest terms, but it is a fraction and it's correct. So that would be fine. But I don't like this. I don't like it when people just write what they see in their calculator screen when it doesn't actually make any sense. That's just a way your calculator has of telling you something. It's not like an accepted notation. Okay, so don't write that down. You won't be getting full points for it. Yeah, I know it's what your calculator says, but convert it into decimal form. Okay, so that I can actually see what it should look like. Okay. Okay, we're going to look at some harder ones. That one's like one that you could have done already, I would think. I think most of you would be able to do it. Okay, this is a pretty straightforward one too. Nathan asked Riel to choose a number between 1 and 40 and to say one fact about the number. So Riel does it, and he says that the number he chose is a multiple of 4. Determine the probability that the number is also a multiple of 6 using each method below. So this one's conditional as well, because the fact that it's a multiple of 4 limits the number of answers we can have for it being a multiple of 6. Okay, there's only so many answers. So when we're doing a Venn diagram, this is nice because it kind of tells us what we should do. I like problems like that where it tells you what you should be thinking about. So it's nice because we're told a Venn diagram would be good. So here really what we're looking at is we're looking at multiples of 4 and multiples of 6. Okay, between 1 and 40. So what's the first multiple of 4? 4. Now is 4 also a multiple of 6? No. So 4 would go in this part of the diagram if we were just listing them all. We might as well. Let's do it. Okay, the next multiple of 4 is 8. Okay, is 8 a multiple of 6? Nope, so it would go down here as well. The next one's 12. Is 12 a multiple of 6? Yes, so 12 goes in the middle. Okay, then I'll just keep going. I'll go kind of fast. 16 would go here. 20 would go here. 24 would go in here. 28 would go here. 32 would go, is 32 divisible by 6? Nope. So 32 goes here. Then 36. 36 is, so I don't put it in there. I should put it in here. 36. And finally 40 itself. Okay, then you do the same thing with the multiples of 6. This is how I would do this question if I was given it. I would just be listing them. And I wouldn't spend forever on it, but I would do it like that. So I'm like, okay, multiples of 6 is 6. 12 is already there. 18. 24 is already there. Okay, 30. 36 is already there, and that's it. Okay, so cool, there we go. So we're trying to determine the probability that his number is a multiple of 6. So how many of the numbers that we looked at are multiples of 6? 3. So that's the favorable outcomes, is 3. Now the tricky part of this question is the total. Because what's the total that we should put under 3? And I'm kind of expecting some people to say the wrong answer, so don't worry too much about it. You're nervous. Does anyone think they know what would go on the bottom of my fraction here? Huh? 7? 6? No. So you're close. You're on the right kind of path. So what we know for sure about the number is that it's a multiple of 4, because Riel said that. Okay, so Riel told us it was a multiple of 4. So what we have to think about is what's the total options for multiples of 4? It is 10. Okay, if I look here, there's 4, 8, 10. There's 10 numbers that are multiples of 4. Does that make sense? It's like, this one's tricky. It really is tricky, I think, because you have to think about, like, maybe listing them out somewhere would be helpful. It's like, if we know it's a multiple of 4, we have 10 options, because there's only 10 multiples of 4. Okay, so it's going to be 10 on the bottom. Then 3 of those 10 are multiples of 6 as well. So the probability is 3 out of 10. A formula here would be, no, you know what, I'm not even going to do the formula. I think it's stupid. Remember the last time I showed you there's like a really long formula that goes with it? This is similar. I don't think it's useful in like any situation. It's better to just understand how to do it. So we're going to skip the formula. Okay, but this is, you can also just do it by listing them. Like, honestly, if I was doing this, I would probably have just listed the multiples of 4. Like, I would just do it like, I'd be like, okay, so it's 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and then I'd be like, I'd circle the ones that were multiples of 6s. So I'd be like, oh, okay, it's 3 out of 10. That's how I would honestly do this problem if it was me. Okay, I would have just listed them out. So you only have to do a Venn diagram if it specifically tells you you have to. It's not a bad way, but it's not the only way either. Okay, so let's look at another one. We're going to get into some slightly more difficult ones. Okay, so according to a survey, 91% of Canadians own a cell phone. Okay, 42% of those, this is from a few years ago, so I'm sure it's gone up, but of those people, 42% of them have a smartphone. What that means, and this is really important, it means that 42% of that 91%. So it doesn't mean 42% of Canadians. It means 42% of Canadians with cell phones, okay, which is a little bit less than 42%, because not everybody has a cell phone. Does that make sense? the difference there. It's a little tricky. So it's like if we know 91%, if I did like a circle diagram or something, it'd be like 91%, so that's like almost everybody, right? Like just 9% doesn't. Okay, that'd be 91%. And then I'm saying 42% of that. So 42% of that shaded region. So that little piece of the pie that wasn't colored in, that 42% doesn't have anything to do with them. So it's a little bit tricky. Okay, we'll see kind of how that plays. Okay, determine to the nearest percent the probability that any Canadian you meet during the month, during the month in which the survey was conducted would have a cell phone. So they're just saying it's that month to make sure that you know that these stats are valid. Okay, so this is a really easy thing. Conditional probability, all you have to know is like that you multiply them together. Okay, so when you're given two different probabilities like this, and one is dependent on the other, so here we have the fact, like obviously if they don't have a cell phone, they don't have a smartphone, right? We're looking at the smartphone is dependent on whether or not they have a cell phone. All you have to know is that it's probability of A times the probability of B. Okay? So event A here is owning a cell phone, and that's 91%. So what we're going to be trying to do here is 91% times 42%. But we can't just type in 91 times 42, because if I do that, I get a huge number. I get 3,822, which doesn't seem right. So does anyone know what I would do instead of that? Turn them into decimals, yeah, or fractions even. So either turn it into like 91 over 100 and 42 over 100, or turn it into a decimal. So instead of 91, use 0.91, and instead of 42, use 0.42. Okay. So then when I do that, 0.91 times 0.42, I get 0.38, which means 38%. So it's 0.3822, which is approximately 38%. So even though it says 42% of the people who have cell phones have smartphones, it's only 38% of all Canadians. So this is just something you have to remember, that when you're given two probabilities like this, generally speaking, what you do is multiply them together. Okay, so the hard thing about this unit is really telling the different types of problems apart and knowing when you have to do this. I know that's tough. It's just a matter of practice though, so we'll try to get you as much practice as we can so that you feel like kind of comfortable with it, but there isn't much more to it. And let's do the last one here. Okay, so I'm going to do this one, and I might, later on, I might pause everything and do another one, because this is a really important type of question. This is sort of what this section is really about. You're going to have a few practices of this on the sheet I'm going to hand out today, and there's also, will definitely be some on the assignment, and there'll be at least one or two on the test. They're not that hard, but you have to be able to spot the problem. Okay, so like I look at this and I recognize it right away. This is a really common situation for this type of problem. So it says, Hillary is a coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on calm days and a 70% chance of winning on windy days. So this is a situation that you have to look for. It's when you have different probabilities based on something happening. So for instance, if it's like on days it rains, she walks her dog 30% of the time, but on days it doesn't rain, she walks her dog 80% of the time. Okay, or if it says he's going to be late for school 60% of the time if his alarm doesn't go off, but if his alarm does go off, he'll be late for school 20% of the time. Okay, it's going to be things like that. Okay, or he has a 30% chance of failing his test if he doesn't study, but if he does study, he only has a 10% chance of failing his test. Okay, it's always going to be this where they give you two different probabilities based on a different scenario. This is conditional probability because the condition is the weather. Okay, the weather here changes our probability. So these guys play better on windy days. It seems like they're better at handling the wind than most other teams. Okay, their stats show that they have a higher win percentage during when it's windy. So it says tomorrow there's a 40% chance of wins. There are no ties. They're just telling you that so that you only have two possibilities. What is the probability that Hillary's team will win tomorrow? So the trick is here is that she has a higher, if it's windy, she has a higher chance of winning. So we have to look at the possibilities of it being windy, of it not being windy, of her winning, and of her not winning. So the trick here is that we have two probability. We draw a little tree. The way you have to do these is drawing trees. Okay, so you draw the first branches of the trees represent windy and calm. Okay, so we're looking at the probability of it being windy tomorrow or it being calm tomorrow. That's what we look at first. Okay, so it says there's a 40% chance of wind, I would put 0.4 here, or 0.40. If there's a 40% chance of wind, what's the chance of it being calm? 0.6. So I put 0.6 down at the calm. Okay, so we're looking at a 40% chance of windy, 60% chance of calm. Then the next branch is win, lose. And same thing over here, win, lose. So what we get at the end, which I'm about to show you how to do, but what we get at the end is we get the chance of it being windy and her winning, the chance of it being windy and her losing, the chance of it being calm and her winning, and the chance of it being calm and her losing. That's what this tree diagram is going to show us at the very end. What should all those percentages add up to? 100, because those are all the possibilities. Okay, so I know it says in the question that if it's windy, she has a 70% chance of winning. So I can put 0.7 here. Now, if there's a 70% chance of her winning, what's the chances of her losing? 30, so I can point 0.30 down there. And then on the bottom, when it's calm, it says she has a 60% chance of winning, so I can put 0.6, and then what would the other one be? 0.40. Okay? Now, this is the tricky part, and the part people kind of forget a lot of the time, is what you have to do is along each line, you have to multiply the two numbers. So I have to multiply 0.4 and 0.7. So if I multiply those together, I get 0.28. What that means is that there's a 28% chance that tomorrow it will be windy and she'll win. Okay, that's what it means. Then I do the same thing down for losing. So windy, 0.4, losing 0.3. I multiply them together and I get 0.12. So what does that mean? There's a 12% chance that what will happen? She'll lose when it's windy. Okay, so it's not just that she'll lose, it's that she'll lose and it's windy. Okay, then we do the exact same thing down below. So 0.6 and 0.6 makes 0.36. And 0.6 times 0.4 makes 0.24. And all these numbers, just like Delaney said, they should add up to 100. Okay, so when they do, that's 30, 40, 76, 80, 100. So it does add up to 100. Okay, so all together they add up to 100. This is actually, I don't think that hard, but you have to be able to spot the type of question it is. So really kind of today, make sure you've practiced it a couple times. Next week, we'll finish this unit tomorrow probably. We'll have our assignment next week to work on for a couple days, and we'll have our test. When we're doing that, make sure you're familiar with these problems, because I don't think they're that hard. They will be on the test for sure, and they're usually worth a few marks. So it's kind of a nice problem where you can get some points, I find. But now it's really important that you read the question and you answer the question. This is like another situation where a lot of times people will just draw this, and they'll be like, I did it, there it is. You need to read the question and answer the question. So the question says, what is the probability that Hillary's team will win tomorrow? So there's more than one branch of this tree that has winning, right? So what two numbers do I have to look at if I care about her winning? 28 and 36. So what I have to do for my answer is add those up together. So 0.28 and 0.36 add up to 64. Yep. So I would say, if I was answering this question, see, it's a 64% chance of winning. So it looks good for her. Okay. See, it's a little higher than 60, because 60 is just her chances if it's calm. So it's a little higher than that because we think there's a decent chance of wind, but it's not super close to 70 because the wind is only 40% likely. That's kind of the logic here. But yeah, so this kind of problem is a really important problem to know how to do. And I gave you a whole bunch of examples. Those are the kind that you'll see. So it's always like, he does this if this, but he does this if that. And it's always a dual kind of thing.